Hello, everybody. So, what is going on today? So, um, the quick version of this is that today we're going to be taking a look at the Python stuff that I've been teasing about for quite a while. Actually, yeah, so we've been talking about this Python stuff for a little while. Hello, people in the chat. We've been talking about doing Python. Actually, give me a second here. I'm going to go see about that. I will be right back in just a second, and then we'll really get started. Okay, sorry about that. So where were we? Right. So we've been talking about doing a stream on looking for Python bugs, specifically looking for. So it's been about a month now. What was I searching for? Medium Python sandbox. So when we started doing these 0 day streams about a month and a half ago now, this post had just come out. Basically, this was somebody who was doing um, I'm blanking on the word here. Bug bounties. They were looking for bug bounties, and they found in one of the applications they were looking at this. I think they found some sort of like cross-site scripting or something in it, and they decided that while it's interesting, they wanted to see if they could find some um, like a memory corruption bug, some way to get code execution on the server. And it's actually it's just a very interesting post to read through. I would recommend it if you have the time. Here is that. It was, but the part that's interesting to me is this. So, um, I think it's a he, went out and found. So the wording's a little confusing here, but the the implication here is that he went on the bug tracker, he looked for segmentation faults that were currently open in numpy, and found one. No, I mean, I'm actually not currently seeing any IRC channels. For the most part, I find the YouTube chats probably the easiest way to do it, rather than having yet another application running. And at least so far, it hasn't been an issue with having too much traffic or anything. Um, yeah. So if you have anything in particular, the YouTube chat's probably the easiest way to get a hold of me. Otherwise, I do have a couple different Slack channels open, and the Twitter. Either one would work. So anyway, talking about this bug. Basically, he went out. He found that certain types of arrays were not bounds checked properly. So when you resized them, it caused issues. And the I guess short version of it is like this post goes through in pretty good detail exactly what's going on. And what I'm hoping for is that I can take this right here. So, just so everybody's aware, right now I'm doing this all completely live. I've done almost no testing for this. So hopefully this doesn't break in terrible ways and we have to do something differently. But, ready to crash? We got to crash. Okay, so right. We know that the version of Python that is currently shipping with Ubuntu works for whatever this bug is. Um, let's actually make sure I'm. Oh, what just happened? That's not what I want at all. We have that. Let's actually talk about what we're going to be doing today. Before we get too much into it, we tested the bug, so that worked. We're going to. Oh no, this is not working at all. There we go. So we want to test that bug. We did that. That worked fine. since that works, the next big thing to do is we want to write a test harness. So the idea here is that we're going to set up a fuzzer for Python functions that should be able to find this bug. And the first thing we need to do for that is to build something that's a test harness for it, so we can actually catch crashes. We can fuzz a function, put it in, see what the result is, save them off sometimes, and catch crashes if they happen. So we have to write that test harness. We're then going to write a generative Python function fuzzer. And then I think what we're probably going to do, and I don't know if we're going to have enough time to do all of this. This is probably actually several weeks worth of notes. But evaluate some other test harnesses. In particular, I'm interested about using HongFuzz, so that's one of the other Google fuzzers for it. I suspect that it would do perfectly fine as the test harness for what I want to do. However, getting all of that set up is a little complicated, and I think it's going to be easier to write our own test harness, at least for the time being. And then, hopefully at this point, we're going to have some stuff to evaluate results. We're going to be triaging crashes, things like that. At least it's a plan. Hopefully all of this works out. But there's a few other things we're going to have to do here. So the short version is, let's talk about what this test harness is going to be, right? So if we're going to fuzz Python functions, we need a way to basically save things off. Ideally what I want is I want this to be a in-memory fuzzer. So we're going to have to set all that up. We're going to have to set it up so that we are able to catch signals. And I think the best way to do this is we're going to actually build a we're going to build all of this in a C, import as a C types module, and use that. And the reason for that is basically that we're going to be able to set up a region in memory that won't get messed with. The short version is that if we're just doing things in Python, the fact that we're fuzzing Python is going to cause problems. It's a little messy, but if you think about it, so let's say that we're fuzzing Python, and we do find like a heap buffer overflow in the heap that the Python objects are using. It is at least relatively likely that if we have that, then it's going to corrupt whatever else we were running in Python. So if all of our test harness was written in Python, it would corrupt that, and we couldn't trust any of the results. Instead, if we write some C for it, we can actually get it all set up and do that. So hopefully, at least the intention is that we should be able to write this all in C, set all of our own handlers, and use that to be able to catch things and not have everything break terribly if we find crashes. We'll see about that. We're also going to have to do something to reset it. So there's two different things that are going to have to be reset. So reset the module state, because the intention here is to fuzz the numpy module. And we're going to have to set up things to every so often reset the entire state of that module. We can do that from inside of Python. And we're also going to need to reset all of the Python environment. And we're going to do that periodically to make sure that everything works properly. And I also want to do a little bit of profiling to start off with. Test runs. So basically we want to figure out how long is some of this stuff going to take? How long does it take to reset the module time? How long does it take to start up Python from scratch on my machine? The basic reason for that is So let's say we've set up a, oh, we're gonna have to do that too. Set up timeouts. So in case there's something that is very long running, we're gonna have to set up a timeout functionality to kill that test case, start a new one, and mess with that instead. So, let's see, am I missing anything? Oh, right. So the reason we're doing the profiling is, uh, hello, new people in the chat. If the testing we're doing takes a long time to start, so Python on its own, and let's just test that real quick. So, um, just import numpy. All it does, and so if we started up Python every single time we were going to do this, it takes at least it takes a non-zero amount of time to start up. And if we just go as far as we're going to copy that over, so I'm not sure if they optimize that at all. I mean, just starting things up takes a few fractions of a second. So if we want to get, so hopefully we want to get, thousands of test cases a second. So we can't afford to start things up, but we need to have an idea of how long things take so we know what to do. I think that's more or less a good framework to start with. So we did this already. So let's set up a little bit of profiling real quick. But actually, it looks like this is way more time efficient than I was expecting it to be. I was expecting it to take quite a while to start up and import the module, but I guess it doesn't matter that as much as I thought it would. One other thing that we're going to need to do. Um, we need to actually set up how we're going to do the fuzzing. And one of the big things that's going to be important for the way that I plan on doing this is setting it all up to run on a RAM disk, because even though I have a SSD on this machine, it's still going to be very slow if we have to keep hitting disk a lot. So let's see here. I think that's about all that we need to do. So let's go into the next step. So we need to create a C-types module to do this. And I'm actually not sure if calling it a C-types module is the right thing. But so C-types, if you're not aware of it, is you're able to write C code, you import C-types, and then you're able to actually load a .so and call things inside of it. And the idea is that if you do this, then you're able to. So some things are good to write in Python. Some things you don't want to write in Python. For example, if I need to be very performant, I probably don't want to write my code in Python. I might want to write some C to do it instead. Or for certain kinds of low level stuff, writing it in C might be better. If I need raw assembly, I would write it in C, or actually inline assembly in C, and then I could do something like C-types to actually do something with it. So I need to actually do that. How do I do that? Thought there was a. I want to see writing my functions. Hmm. Oh, do I not have to do that? That's interesting. For some reason, I was. Oh, it's one of the other foreign imports. So a couple different foreign imports libraries. Some of them require you to write functions with certain prototypes to be able to use it. It looks like C-types, though, will just let me take a function normally and I write Python around it to do the things I want it to do. So let's set that up real quick. So, do I want to make a new directory for this? We are currently doing This one. How do I want to organize this? Because this is going to take a while. I want to make sure it's organized reasonably well. Hopefully this doesn't break everything because there's now a subfolder with the name of the module we're going to load. But we want to include standard IO. Let's actually just really simply set this up. All I want to do is it's going to be a void function. We're going to set up a test. It has no arguments. And all I want to do is I want to do printf this loaded. That's it. What's the right flag for GCC export function? I never remember the right way to build an SO with my functions exported in proper symbols. Looking things up is a something I frequently have to do for this. So I need to do that. Yeah. So GCC, in order to compile it pick, we need the file. And we give it a test.so, file test.so. That's an elf. That's a .o. I wanted a .o, not a .so. Because I also need to do that. Yeah. See, I knew there was a way to do that properly. I wanted to do share. There we go. Let's actually Okay, where were we? We want to come in here. We have our .so. I should be able to, if I understand how all of this works, which, is reasonably generous assumption. Import C types. What was the code for that I needed to do? I want to do CDLL, right? Which is a little weird given that I'm loading a .so, but let's do it the way they recommend doing it. From ctypes import star, we're going to load ctypes slash s.so. And then to actually call a function, it just works. Is that how that works? Nope. Screen shortcut and not what I actually wanted to do. So tester, no. Helps if I close things, dot test, was that right? Only edine and et exact, change mod plus x ctypes test.so. Not what I want at all, is it? Why am I failing? What? That's a... Oh. I thought we fixed that. Hmm. That's not at all what I wanted. Test.c-o test.so. Right. Uh, no. Yes, that's a shared object. That is what I want. There we go. Right. So we're able to create these functions. So we have a C function that we then actually are running from Python. And the idea is when we set this up to register some signals, so we should be able to set up a test. We'll have a function to set up a test, and then a function to actually. So what do I want to call these? So let's do a void init to actually set everything up, and then we're going to run a test, which is going to be it's going to accept a car star func. For now, we'll just print out what that function is. We also have our init. And while we're at it, I would never remember the right syntax for that. So, yeah. That is not what I wanted to do at all. I want the absolute most basic makefile. I never remember. This is one of many things that every time I do it, I have to look it up because it's just slightly outside of the kind of thing that I do regularly. So I need to define a thing. Test. I need to make it a thing here. I need to supply files, I believe. So test.c. And we want to do gcc-shared-o test.so. Then percent dollars. I think that's the right way to do it, right? Yeah, it doesn't matter. I'm not gonna. I will do it the wrong way and not care too much. Hmm. Hmm. I'll just compile it myself. This... Oh. There we go. Test.so. That is a shared object, so it should work fine. Okay. So if we come back down here, that's the wrong one. Here, we want to first init this. Tester.init that, and we set up a test with lure. Yeah, I had it with the wrong name and was being dumb about it. Okay, so both of our simple functions work in our very simple setup. So what else do we need to do? We have this set up. We need to actually initialize things properly. And I think the part that's going to be super important here is we're going to actually set up a signal handler. What signal are we getting when we do this? So we do a test.py. Goes through, it runs, it eventually crashes. We get a core dump. Um, so signal, is that the one I want? No, it's man. Well, we'll start here. So we're gonna have to actually set all this up. So pound include signal.h, and we will need to set up a signal handler. Void handler accepts an int. I think it's the signal that it's accepting, but I'm not sure. I can never quite remember what the proper argument is, but and let's just exit cleanly. Did that. We then want to call signal. The signum that we want is a segv. I believe that's the proper name for it. Given that Vim highlighted it, I think it's probably correct. And let's try that again. Warning. Oh, I didn't include standard lib. Found include standard lib.h. There we go. So if we run this, hopefully this doesn't break everything. That looked pretty reasonable. And what we want to do now is we want to do, I want to open up test.py. I want to then yank all of this, switch back to this, and put all that there. So if all of this works the way that hopefully it does, what we're going to see here is we hit our signal. So this actually works the way that I was hoping it would work, in that instead of starting up, running, and crashing, we're instead starting up. We still hit our seg fault, but instead of just crashing, we're handling it properly and we're exiting. And the idea is that if we do this, we're going to be able to write a simple wrapper around everything we do. We'll be able to catch these crashes when they happen. We can actually do something with it. At least that's the theory here. Sorry, I'm trying to drink a little bit more because usually the reason the streams stop at about the 2-hour mark is that's the point where my voice no longer works properly. So hopefully if I drink a little bit more, we'll be able to get a little bit more progress today. Because I mean, I have most of the afternoon free, so hopefully we'll get something decent done. So we have this here. We are now setting up this, but we're going to need to do a little bit more than that. So one of the things that I want to do here is I want to set up a page for ourselves. Unfortunately, we can't just trust to use the heap. At least I don't think we can. So if we talk about what we're doing here, one of the things we very much don't want to have happen is when we're fuzzing, if we corrupt, we are going to corrupt memory. That's our goal here. But the way we're handling catching crashes is running in the same process. So what we need to do here is we need to set things up in such a way that even though the Python memory regions are getting corrupted, our test harnesses isn't. The easiest way to do that, well, one of the ways to do that, is we're just going to create our own immapped region and hope that all of this works out. We're going to set up some guard pages on either side, and ideally all of this is going to work out in such a way that it doesn't matter that we're getting memory corruption, it won't corrupt where we save off each of our test cases. Again, that's the theory here. We'll see how well it actually works out. I think there's something else important here that I'm not explaining, but Oh, right. The way that we're doing this is one way to do this. It is not necessarily the best way to do it. We could talk for quite a while about the trade-offs between. So we're doing things in memory, and we're fuzzing them from inside the same process. There's an entire set of trade-offs to doing it this way, as opposed to using something like ptrace to hook into the function and do things, or to do something like set up emulation and like I'm gonna fuzz from outside of QEMU and attach with a debugger and catch things that way, or use pin, or I mean we could even set up our own hypervisor and catch crashes that way. All of these are different ways to do it, and all of them have their own set of trade-offs. The reason I'm doing it this way is because it's relatively easy to do and it should be relatively portable. I should be able to set all this up, and when I run it, it should just run. It should run on my machine. I should be able to throw it up at EC2 and run it there and have no problems. And for the most part, it should just work. It should be relatively high performance. We'll get an idea later exactly what that means. But my hope is that this should be like I should be able to get quite a few tests per second. We'll see where I end up, but hopefully this is relatively performant. Um, yeah, so we're going to set this up such that there is a region of memory that, even though we're getting memory corruption in the Python part of virtual memory, it hopefully isn't going to touch any of this stuff. So what we're going to do here, so we set up a signal handler already. Let's set it up before this. So we want to immap. So we have a void star buffer, and we want to do buffer is equal to immap. If adder is null, then the kernel chooses the address. I'm okay with this. Null, our size is the size of a page. 4096 sounds pretty reasonable. Let's actually make it a little bit bigger than that. So we want this to be big enough that our fuzzing never creates something bigger than that. One page is probably fine, but we can make it. Memory is cheap. We can just give it some more space. I then want to do protections, and I want to do rot read rot write. So we just want this to be read write. Nope, that's not what I wanted at all. And the flags are updates the mapping are visible to other processes that map this file and are carried through to underlying file. That's not exactly what we want. I don't think we need to actually set any of the flags. Oh, I don't actually want to use immap, do I? Do I? I mean, I guess if we back it by a file, which is kind of what we want to do, isn't it? Hmm. Actually, let's just give that a try, right? It's quite possible that we can actually just malloc some memory here, and that this just works. So I want to do a printf of the pointer for our buffer. When we do a test, I want to do a. Sure, we're just gonna stir copy this. What's the worst that happens? And we should be able to do a printf s of our buffer. This is where everybody goes, wow, you are very loose with your coding here. Yes, I'm fine with all of that. I start to make my errors go away though. And I don't have a string.h. Pound include string.h. They all went away. Look at that. So Python test C types. Oh no, oh no, oh no, oh no. Well, everything is breaking. What's happening here is, that's a very high PID. Um, Clearly what I'm doing here is not working the way that I want it to work. Oh, we're not calling exit anymore. Duh. How did that happen? How did I lose that? That looks pretty reasonable. I'm not happy about the pointer it's returning to me. So that means, at least that says to me that we're, well, so if you remember some of the CTF stuff we did, we can cheat a little bit and make malloc return a mapped region, which effectively does basically what I wanted to do anyway, except instead of having to do it all myself, I can make malloc do it instead. So that looks like what I want. Except I also want to do this. Before we stir copy it, I would like to memset. Well, stir copy is going to null terminate it, right? Doesn't it? I like how I'm discussing whether or not stir copy does what I want when the general guidance of anybody who is trying to write secure code, the answer is I should not be using stir copy. However, because I'm testing it here, it doesn't matter that much. And remember, if you're checking lengths of buffers, you're being inefficient. All those cycles being wasted. Don't check your buffer lengths. In any case, because of the way we're doing this, I think it's actually safe because there's going to be a non-writable page at the end of that buffer anyway. We're fine. I am completely lying to you. This is not safe at all. So I want to set up now. Do it in a window we can actually read things in. So test case is equal to 3 things. So this is going to be our test case. Tester.test test case. Python test C types. Test case is not defined. Oh, helps if I can type. Oh, we set up a test. We want to eval. So we can do a little bit better than this, right? So if I do, I never remember what the difference between the Python eval and Python exec are. Eval versus exec. So if I do eval, it returns what it is. This function. And so the reason why we're doing this is because I want to be able to control globals. Because I want to be able to specify use this numpy and be able to reset it easily. And I also want to blow away the locals, and basically I don't want them to mess with stuff. I want to be able to control it as much as possible. The globals dictionary does not contain a value for the key built-ins of reference dictionary of the built-in module built-ins under that key. So I want to do, to get rid of this, to put this up here. Do it over here. Exec test case, and it's a diction. Globals is a dictionary, right? Yeah. NP is NP. I think that did what I wanted. So we initialized everything, we got our immapped region. This is the function we're testing. And then it prints out this, we run it, we hit our signal, and we actually dump things out. That looks like what we want. Still looks good. We want to do, oh, I have caps lock on. We've ranted about that on stream before. But we're going to do a little bit more here. So we want to create a function like this. We want to run it. And the reason we want to do this is because we want to eventually be able to build functions. When we get into some of the generative stuff, I want to be able to create multiple functions that are going to build different things. So I should be able to say, here is a function which will return a array. So the fuzzer should be able to create an array and have a function that's able to create an array with, and use that to be able to set things up rather than having to somehow kind of luckily get to where we are here. So we're going to do that, and we're going to do test case. We're going to call that a test. Down here, test case plus equals /n test. That looks like it's all working the way that I want it to work. We declared our function. It gets printed out. We call segfault. It will print it out again. The only other thing that I think we need to do here for this is I want to not just print it out. Instead of printing it out, I want to do... I never remember what the difference between them is. Man... and open? Yeah, I never remember the right things that I have to include to write to a file. I don't think it's actually most of these things. I think I just need fcl.h. But what do I know? So int fd is equal to open. Let's actually build up a string here. So car star file name, not a car star. Car array though, let's make a big array. We want to do a sprintf. So what do we want to call this? So we have crash. We need to give it a unique name. So let's just give it %x. We want a sig %d dot imp. That seems good, right? But the first argument to this needs to be our file name. We need to supply a, we also want to, so %x is going to give, we want a random number that's going to return, or an incrementing number, would be ideal, but we're going to pick a random number. And hopefully everybody watching this is going to groan when they see my method for generating a random number, which is and then %d is the signal we got, so I want sign. So cd ctypes make, whoa, that is many, oh, open file name. I want this to be %p, so it stops yelling at me. And man, to open, we path name and flags. And I want, what is the, I want O, those are flags. I do want flags. So I want O read write board with O create. Yeah. It's a random number. This way, I'm not creating it myself. I am trusting the entropy of my system. And we want to write to fd r buffer. And the length we want is strlen buffer. Make plus def, right? Ah. Didn't realize that was in a different library. Okay. So we now have a crash. So if I do by cat our crash, it's a function we had. That actually worked. What is that T for? I'm not sure why why it's being highlighted like that, and what the T flag does. I imagine it's the create flag I passed it, but I thought that's what I had to pass. Hmm. It works okay-ish. Except I want it to go into a crash directory. Crashes slash crash. Python test. So, oh, helps if I recompile that. Python test C types. Yay! They're unique identifiers. So for people who didn't quite follow that one, the way that I'm generating unique identifiers is by just using what malloc is returning as a pointer. Is that going to be unique enough? I think it's going to be unique enough. It doesn't mean that if we get more than 24 bits worth of crashes, I think we're going to start losing files. I don't think I care about that, though. This works good enough for now. So, where are we at right now? I think this is as far as like what a very minimal test harness is, this works. It will catch, so we set it up, we save off what we're going to test, and if we're going to crash, we save it off and we keep a copy of it. At least as far as the C side works, that more or less works. It's kind of gross, but it works. So let's go on to the other piece of it. So the other piece of it is we need this Python side of things. So what we want to do is let's actually, best way to do this. The test C types is fine. I don't care about you anymore though. Test harness.pod. Actually, do it this way. Okay, so I only need to load the library once. If I initialize it, that works fine. I want to import gen, and I want to do test case is equal to gen.generate. And so we're going to create a gen module, which generates our test cases. We then set all of this up, and I am relatively okay with that for a very simple thing. So I just need to do this, def generate. We want to return, what do we want to return? Test.py. yank all of this. Put. We get rid of this line, those 3 lines. And so our new test harness should be very simple but work. It indeed works. Ooh, and we're getting a different one now because our we changed some of the formatting on it. So this does one test case, which I guess would kind of work, but it's not sufficient because inputs that we said we wanted to actually declare a function too, didn't we? Print YOLO. So we now have this inputs, we now have this array of inputs. We're going to want to have eventually this this inputs eventually this inputs array is going to go away. But at least for the development process, we want to create a generator function which will return both a function that crashes and a function that doesn't crash. So this way we're going to be able to test that not only does our test harness work when we supply something that crashes, but it also works when we supply something that doesn't crash, because if it doesn't handle either of those, we lose either way, so we need to make sure that works properly. So, turn random.choice inputs. What this should do is test is not defined. Yeah. Equal to random.choice inputs, and we want to do input is equal, or imp is equal to def test /n plus imp. Unfortunately, this is not going to set up our Python's hard. We want all of this indented properly, don't we? So if we want this to be indented properly, what's the best way to do this? Lines is equal to imp dot split n. This is a really gross way to do this. I'm not happy with this at all. That would do what I want it to do. Well, that's not right. Oh. Turn. Helps if I can type, doesn't it? Not to do it all what I wanted. Okay. Yep. I did not want to do whatever that change was. Oh, I need to do that, don't I? Wrong order. We're gonna get there. Yeah. Quim in the chat is correcting me and for being terrible, but that's what we did here. So this is a very, very, very simple generator. We're going to create things, we can test things, we can catch crashes. What else do we need to do here? We also need to be able to run multiple tests. And I guess for the most basic version of this, let's just keep running until we catch a crash. That should be fine. Well, you know what? Let's get rid of printing it out. There's no real reason for us to print it out all tons of times. We have that. We did this. Let's come up here. File 1. Do that. Right, so we have a test case. We generate a test case. We then set it up as a test in our C. We then add the call. Not do that here. Let's do it here. So what we're currently doing on the stream right now is we're trying to write a fuzzer to find numpy 0 days. So there's a post from actually I can put that in the description, shouldn't I? Here. Sorry, just a second. I'm going to update this. So there's a post from I don't actually know who the no, go away. There's a post from somebody on their blog that came up about a month and a half ago about finding memory corruption bugs in numpy or Python in general. So the idea is that we're going to find some of our own. So far we've written. So where are we on our steps here? So we're doing kind of in-memory fuzzing. This looks kind of reasonable. So we have test cases. We're testing them out. We're working. I do want to get rid of printing them. I'm doing them in 4, aren't I? So we don't need to do that anymore. Make this. So we are kind of doing in-memory fuzzing. We're catching seg faults. It might be worth registering some other ones. I need to think about that one before we actually set it up. We're doing it in C types. That works fine. We're getting a memory region that won't get messed up. We haven't done the resets yet, and we haven't done timeouts either. But the test harness part kind of works. Like it works well enough for it to fail terribly. You know. For one, we're currently only dumping things out like that. Let me think about this for a second. The next thing we need to do is we need to start writing something to generate Python functions. That's going to be a little bit more, that's going to be probably much more tricky than what we've been doing so far. Because we need to write something to go through, create a numpy array, then be able to resize it, and access a sub-object inside of it. If we can write a generator to create a function that does that, then we should be able to find this. But we have to actually be able to do that. And one thing that's probably worth doing is to add the ability to capture objects as they come back. I think for our first version, we're not going to include that. But at some point, we should be able to basically build on the stuff our fuzzer finds out as it goes. But let's see here. I've been doing this for about an hour right now. I think I'm gonna go take a few minute break. Go grab another drink. I should be back in about 5 minutes. So 12:07 Eastern. Uh, but I will be back, and I will hopefully see most of you then. But I'll be right back. Okay, so and we're back. Where were we? So we currently are generating very basic functions. And now we need to be able to generate something that actually exercises this. So let's at least take a look at what this function looks like. So at crashes. So at the most basic, the way this thing looks is we initialize an array with some elements in it. We then resize it, and then we try and access something that we resized it to. Hmm. So at its most basic, we want to iterate through all of the things in numpy. Hmm. Or numpy as a lot of things. So one of the advantages here is our generator can use information that Python knows about Python objects. Um, so for Prozac Boy, we're not trying to escape the sandbox per se. We're trying to find bugs similar to the one that that blog post found. So in his case, he found, at least the supposition is that it was found by looking at already reported crashes in NumPy. And the idea is that we can fuzz that. We can try and find new bugs that nobody knows about and go find some Ode in NumPy. At least that's the theory here. We'll see if we can actually get there, but it should be definitely possible to fuzz the NumPy in a method similar to fuzzing other interpreted languages. That's one of the more interesting things about what will probably be a series of these posts or streams, is that the techniques we're using here are not specific to Python. Even though we're fuzzing Python code, they're not specific to Python. So if at some point, hopefully they should be able to transition to, if you wanted to look at something else too, minus some of the specific things. But as I was saying, we can take advantage of the information that Python has about the objects available. So for instance, we can do something very simple. We can say, for object in dir numpy. So we're calling dir to list out what all the objects are. Crap. np.square root. That's a function. That's a u function? What's a u function? What is a ufunc? The idea is that we should be able to take advantage of the information Python has to help us create functions. Universal functions? Hmm. Ah, that's interesting. Okay, so they have created their own wrapper functions that are ufuncs. Hmm. Okay. Maybe we'll take a look at some of these things. There's not a huge number of functions. I was kind of expecting a few more than this, but this works. So one thing, at least the kind of theory that I'm working from here, is we should be able to fuzz these functions with different types of arguments until it returns something that works. So for each of the objects in numpy, let's actually get the actually let's write some code to do this, because just import numpy as np for obj underscore in your np. Obj is equal to np dot. Okay, I'm trying to remember what it is. Import numpy as np. That's a thing. Access it that way too. Has no. Okay. Get module function by name. Get adder. That's what I wanted. This is going to return the actual object, the numpy object. If obj dot np dot class, is that what I want? Yeah. No, I want to Python check if object is function. Like, I can compare it, but I think that's not the right way to do it. Oh. It used to be deprecated, but it is now undeprecated? How did that? Okay, this is a complete tangent, but I am really curious what happened with this. So there is a. It was deprecated, and someone decided it would be better in Python 3 to have it again. That's fascinating. But we can just do this. That's way easier than I thought it was. If callable obj print obj underscore. So Python. So these are all of the functions, or all the things we can call from numpy. Interestingly, this includes that square root function that was a ufunc, as opposed to a universal function as opposed to a function. So we should actually be able to do things with it. So we have that. So what is a ufunc? A universal function is a function that operates on ND arrays in an array by element fashion, supporting array broadcasting, typecasting, and several other features. All right. That is, a ufunc is a vectorized wrapper for a function that takes a fixed number of scalar inputs. These are a lot of words that are mathy and I don't fully understand. So, let's think about what we need to do next. So, one thing I need to be able to do is, if the test case succeeds, I need to be able to apply it back to what we had. Let's leave this in for now, but I don't think we're actually going to use this quite yet. Because the more that I think about it, that's going to be pretty complicated. We can go through here. We can call all these functions. Or to numpy as n. A little easier to do that. We'll create a slicer function here. Callers is going to be array. Ooh, callers. It object or is one list comprehension? Sure, I can. For obj integer and if callable, get better. And this is why people hate to read my Python code. So this is a list comprehension that does the same thing as this loop, more or less. It's slightly less efficient because we're calling getOuter twice, but it does the same thing functionally. Well, I think about this. I have all these functions. Oh. Oh. That. So what are we doing here? I only want to register a tested function if it didn't cause a Python error. If it didn't cause a Python error, then we might as well throw it away. It didn't do anything. Where were we doing this? Python test harness. Okay. I wanted to test and make sure that this still worked. What changed? Pointer we're getting back is not what I wanted it. I wanted it to be a very large pointer. There we go. I think we just ended up slightly smaller and it worked fine. So the reason I've been testing through these multiple times is because I wanted to make sure that wrapping it in a try except didn't mess with the signals for some reason. That's one of the things I'm not actually that like. I know vaguely how Python exception handling works. Like I understand that there's a try and I can accept certain exceptions, catch them, and handle them. And that doing this try except pass is apparently the work of the devil, and I should never do this. I'm a bad person for even considering it. But how they actually do it internally, I'm not as familiar with. So I wasn't sure if this was going to also capture the signals that we were capturing up here. It looks like it's not, and that's good. But no, I'm sorry. I don't want to tester register. I want to gen.register. Right? The tester is the C code. We don't need to register with the C code. We want to register with our generator. Looks fine. Ooh, that does not look fine. Fine. Yeah, that's what we want to have happen. Okay, so we have this. We want to go back to our generator. Generator? Generator. Generator? Where's our generator? There's our generator. We have callers. Oh, we are still not calling init, are we? Gen dot, which is kind of dumb, given that this is a module. We totally should be actually setting up a module initially, not a function. But it's possible we want to reinitialize this at some point. So at least that's what I'm going to say, so I don't have to do more work. Where are we? I'm going to. So we have a array of callers, which are all the functions we can call. Except we're getting the functions this way. We don't actually want the function. We want the actual name of the object. So callers is now an array of strings, which are all the things we could call. But its most basic, let's do instead of random choice inputs, we're going to pull something from callers. We're going to do random.choice callers. This would now be something like, oh, no, I want to do space np dot. We're now actually going to try and use one of these callers. Like that. I actually want to return it. If it works, at least out of range. Oh. I never remember exactly when that does and does not work. Wow, this is that totally works. What exactly we're dumping back to ourselves here, though? So we now have functions we can call, and at least some of the functions are doing a thing. What's our best way to handle this? Fail out. Wow, that's putting out so much information. Running unit tests for numpy. I do not want to run unit tests. Why am I running unit tests? That almost certainly is not what I want to do. Okay. There's at least one function in there that I want to kill. Seven. What is running? Is it a test? Okay. This is not quite doing what I want it to do. Because what I want it to do is I want to. I apparently need to remove at least one function out of this. Simply because I want. Dumping a bunch of information that I don't care about. And it this just tons of unit tests. So much information. I should have a good way to get rid of it. I want to know what it is that we're calling to cause all that shit. Okay, just for this, we'll just print item all the. Hate that I'm doing it this way. Oh. Dash R. This is the one. Okay. Test harness. And 5. Going to append, not write. Pausing all of that because none of these look like they should be. For one, I'm getting pretty good throughput, which I'm kind of happy about. I was concerned that the throughput would be bad. This throughput isn't terrible. And to be fair, we're not doing anything super complicated, so. But getting pretty reasonable throughput is pretty good. Like in that very short time frame, we got 9,000 test cases, including dumping way too much information to the screen. Oh, you know what else I can do? I can say register is not going to do anything. It's going to .d and Right func. Wait, is this really what it's doing? So all of these are still causing seg faults? Or Python exceptions, not seg faults. Okay. Uh, okay. So, what is causing? Oh, show config dumps out a ton of information. So, but the thing that actually it's actually dumping out info. Don't want info. Okay. Info is the one that's dumping out a ton of crap. Can do. But info and show config are probably things I want not to call. And option in uh, um info go up. Looks like what I want, more or less. Print that. Back to doing choice colors. Look at that. Okay, so that works, at least reasonably well. But we're not getting stuff we want because we're not actually setting up very many arguments. Are we? Oh. Some of these do actually return. That's good. Junk. So we currently have it set up so that it will call all the functions in numpy. Is that what we want though? I don't think that's what we want. So the idea here, at least the way this works in my head right now, is we should be able to set things up so that each line in a function is going to call something out of this callers array. When we initialize it, we're going to initialize it with all of the things in the numpy module that we can call. We're going to need to specify arguments we can pass into it. We're going to have to be able to say there's a random number of arguments for each of these things. And when we call this register function, I want to be able to say, here are ways to initialize new objects. And there's a basic version of objects. So, oops. what do I want to call these? I want to call these args. So I want to have a string, one character. I want to have a string that is 100 characters. I want to have 0, 2 to the 32 minus 1, 2 to the plus 1. I want 2 times 32 minus 1, 2 plus 1, 64 minus 1, plus 1. Also do 2 to the 32, 4, 4, not 26. Negative 1, anything. Um, an empty array, empty dictionary, a set. Looks like a decent start, right? Just a general set of things. That looks pretty reasonable, I think. Well, let's also make a slightly longer. And a time. Yeah, that seems fine. For that many. The idea is that we will, when a function returns something, I want it to go in here. So args.append. Types, types, empty thing, full types. For arg in args. Types.append eval arg. Because eval works slightly differently, right? If I do eval -1. Oh, and I actually want to do sure. Hmm. Remember, kids, things that are gross are gross. So we have this. This is basically just going to create things for us. Um, this seems pretty reasonable. Eval args. We can just create one of each type. I think that should be fine. So the idea is that whenever we register a function, we want to do. Hello, Roman. Welcome to the stream. The ret is eval arg or eval func. If ret dot class in types, if not, ret in types dot append ret dot class. If else, if elif Um, random dot random. Random dot So if we've never seen this class before, we want to keep it. Or let's say one in every 256 times we see it, we're going to add it anyway. So we're going to args.append func. It is pretty simply that we're just going to so this is trying to think of the best way to do this, right? So this is tricky. I don't like this. A 9. What is fascinating in the chat? It would appear that there are at least a couple bots, maybe, watching this. Um, where was I? So if I'm doing, I want to have a function that's going to return a class. So when I have something like or dot array, when I have something like this, how do I do this? Okay. Hopefully that makes it a little easier to read. Um, but where was I? Before I got distracted by the chat. um, so I want to be able to create a function. So when we do, uh, where am I right? If I'm here and I do def test np.array a, or a. So this is one of the things that could be declared and work. I want to be able to call np.array test like this because that is clearly a different object. So test doesn't return anything. So if I do test turn np.array a np.array test, like that's a thing. Although it's apparently the same thing. It's interesting they unwrap it like that, but I mean, the general point being that I want to be able to pass these NP arrays as arguments. So I need to create a test, which is an object that we can call. And I want to be able to register them. So how do I do that? So I'm going to call it a imp sent x. That is one way indeed to do it. ID. Imp ID is equal to random dot rand int. So I then should be able to do, I want to return imp plus equal slash n imp. So I think this works, right? So now I should be able to get unique input ID functions, which will let me supply them. Because when we start doing arguments, I want to be able to say, so if I have def imp one returns mp.array a, I want to also be able to have def imp two return np.who one, like that, so that when I do int two, it would actually do a thing. Yeah, see, this causes an exception, and it, fails like that, but that's basically what I want to be able to do, because I want to be able to build up these arguments of things that have arguments. Um, Also, while we're fixing things that I'm doing wrong, we have this here. We want global args types callers. We added that. We also want to be able to call these functions. So, when I call args like this, I should be able to have a definer. So, we split our function. The caller is lines -1. So the last line is going to be imp underscore the ID and to call it. And the definer is /n dot join line. So we now have a definer and a caller. So I want to say that. How do I want to do this? This to be that. So args is now two things. It is now a caller or I want a definer and a caller. So now I should be able to say, here is a way to define inf underscore one. And here's how you call that function. So when I come down here, I should be able to set that up. Let's just test this out before we get too far ahead of ourselves. Invalid syntax. Oh, help if I put a comma at the end of that. arg1 must be a string or what? for arg in args. Arg. Oh, for okay, so that works more or less. And we want to randomly create. Okay, so we're setting up arguments. That works. I also want to be able to set up new callers because I want to not only be able to call a function. So I have np dot whatever is a function. I also want to be able to have the ability to call. So if I initialize an array, I need to be able to call the methods for arrays. How do I want to do that? I think the way to do that is we're going to do the exact same thing here. Defer is equal to defer caller is choice imp to defer plus int. So we want to append to this the way to define the thing we're doing. I'm sorry, we want to append our test case to this. So we want that. We then want to get rid of this part. We want to return caller. And I think, make sure that all of this works still. Hopefully we didn't break everything. Yep, that still looks like it works. I want the ability to add to callers too. So args.append we're appending to, and callers.append definer caller. I'm a little surprised that I'm not. Did I get rid of the ability to save off functions? Wait, what? Mm, you just failing me pretty hard. No. Okay. Fortunately, because of how I'm doing this, I'm. Oh, is this the wrong syntax for that? Global types, global caller. No, we're still not doing that. Hmm. Why? So this is wrapped in a try except. I want to continue. Oh, because I can't eval it. Duh. That's me being dumb, isn't it? I can't eval it because it's not an expression, it's a actual thing. What I should be doing here, does exec do the same thing? No. Hmm. What's a good way to find out? Well, I can't eval it because I'm trying to define functions and stuff. So, what is a good way to figure out what the type of the function we called is? Well, if I do that work? That does work. Okay. So I could pass in as an argument what return. That sounds messy as shit. Wow. Is there an easier way to do this? Hmm. Like I really don't like that. That might be my way of doing it. Hmm. I mean, I guess this works. That just seems so gross. Hmm. Gotta be a better way to do this. Running into the Python was very much not designed for me to be able to do the things I am currently trying to do. Hmm. You know what? I think it's actually been about another hour here, and we haven't gotten very far. But I think I'm gonna take another short break here, refill my cup again, and I will be back in another 5 minutes. So thanks everybody for sticking around, and I'll be back in another minute. Okay, and I'm back. And I have another drink, so it sounds like my voice is actually holding out better than usual. So we don't need to stop right now. So, where were we? Oh, hello, Ivan? That's the right way to pronounce that. Welcome to the stream. Hopefully the break there did not chase you off. So, before the break, we built all this code to try and start generating functions. And the first version of it works fine. Being able to say, here are all of the callable things in the numpy module. Now what we want to do is if we call something, if we do np.array abc, well, import numpy as a, if I do this, that returns something to me. So I want to be able to have a nice feedback loop here. I want to have not just, I want to be able to call not just np.array, I also want to call np.who with np.array abc. Because in theory, that's going to cause issues. Also, I want to be able to do this dot resize 0 like that. Because that's the way we're going to get to the bug we already know about. So we already know about one memory corruption bug from the blog post in the description. What we want to find is we want to find more of them. Because ideally, if we find more of them, we're going to find interesting things. And hopefully, if our generator can find one, it can find a lot of them. I don't know if that's true or not, but that's the theory we're working on here. So what we need to be able to do, hello, Daniel, is we need to be able to have this feedback loop. Unfortunately, the way I was hoping to do it was with an eval, because eval will return what the string does. But I can't eval a function. I hate doing it this way, but this is going to work, and right now that's a little bit more important. So lines is this. We have a caller and a definer. So I want to do exec definer plus out.append plus caller plus that. This feels so incredibly dirty. Like, this feels wrong. Huh. Is the live CTF video the one from DEF CON a couple of years ago? Um, so, for people who aren't watching the chat, Daniel is mentioning a video from some of the Vector 35 guys. I know they were talking recently about they finally got around to posting some stuff from DEF CON quite a while ago. So hopefully that's what it is, because it sounds like an interesting video at least. Ooh, so close. Um, NP. Oh, that. Okay. I think this works now. That here is fine. So I think doing it this way will get us part of what we want. And so this is one of the things that I was concerned about. You notice it went from going along at a pretty good clip to now it's kind of crawling. Hmm. Because as we're going through here, we're getting more and more objects that we're trying to keep track of. Hmm? That's odd. So we're doing that. Um, oh yeah, no. It's actually a really interesting video to watch. It's got a number of the like legit BS guys, I think, doing some CTF solves. I can find it. Oh, and you get to see Jordan in a vest and tie. That's exciting. But yeah, there's 4 different people who were solving, and you can see the different teams trying to solve things. Definitely a good watch when you get a chance. So where were we? So we have this. We're setting up callers. We also need to set up arguments. If I do for I in x range 0 print I. Okay, good. I'm just picking 5 here at random. Random. Um, so this may or may not work. I'm hoping it does, but I don't know for sure. So defer, comma caller is equal to random dot choice args. Imp is equal to defer plus imp. Imp plus equals arglist dot append. Really, I didn't realize a lot of people were doing it in one. I guess 2 years ago it might have been a little bit better. It probably also has something to do with the costs, because you're supposed to buy IDA for each OS you're running it on. So they might already have the Windows one and don't want to spend the extra $1,500 on the Linux version, and they want to run Linux for CTF stuff. So arglist.append caller. Arglist is equal to that. Imp plus equal comma dot join arglist plus equal that. Okay. Well, that is definitely doing things differently. Like we're definitely getting new printouts there. So if Federico, if you're asking what the alternative to IDA and Linux is, as opposed to running on Wine, you can't just run the Linux version of IDA. That's actually what I have in this VM and what I usually use it for. Um, like that's the version of IDA I'm most used to is the Linux version, not the Windows version. But that's because everything I do is basically on Linux, and has been for years. So except for playing video games. Um, so I never wanted the Windows version of IDA because I'm used to doing stuff on Linux to begin with. So, but if you are used to using Windows and you get the Windows version, why would you get another version too? So, yep, still haven't gotten crashes, which is a little unfortunate. Print colors. Print so much stuff, isn't it? Well, there's no problem with a little bit of derailing things. Hmm, that's interesting. Um, yeah, it's quite possible that we want this value to be much higher. Man, we're actually getting much better throughput than I was expecting to get. Hmm. Long, too big to convert. See, I'm really curious about this one. So we're actually getting something which is capturing inputs, which I was not expecting to get at all. Oh, I'm being dumb. Hmm. 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 So what's causing that search thing? Search results for. filter whatever this function out is too. It's gonna be like a dock thing, right? Or help? Hmm. Causing that? Oh no, you are not a problem at all. Um, that. Or are we already filtering out info? We already filtered out info. Where is this coming from then? I don't want to go back to dumping everything out, but I guess we can for just a little bit here. Oh, we can do it here, can't we? Hmm. Open, dump, append, write, definer. Do that. Really? That's super exciting. I did not expect that already. No way. That can't be right. Hmm. Okay. We clearly had some other problems we caused there, but this is one of the things that's going to be difficult to try and triage as we go. Is that we're going to end up. Oh no, stop that. Okay, so if we edit this, I can type that is a obj2sc type is the other thing we want to filter out because whatever this is, it is not giving us useful information. And get rid of this. What? Okay. NP look for. Okay. Okay. So this looks good. We're no longer getting those like docstring stuff. Ooh. I want to see if I can figure out how to remove whatever this is too. Yeah, I'm pretty sure whatever that crash was not. I would like to know what that crash was, but I have the feeling that it was not what it That's a lot more exciting. F. So this really gives me the feeling that we're this followed by a crash very shortly afterwards is hilarious, and I'm curious if it's related. But for now, let's give this a second to run. Python test harness. Hmm. Like it doesn't make. I don't understand why that is causing a crash. I mean, another option is we actually just. So what happens if we don't handle this? If we just let this crash, what happens? Um. Hmm. So if we turn off handling crashes and we just let it crash, we would get a, and I can turn on core dumps. We could just get a core dump and take a look at that. But I'm not sure I want to do that because that's going to be very difficult to read through, I think. Um, like that is. Wait, what? I'm handling seg faults. Hmm. Yes. So we set up a handle. So we are catching a signal from C types, and there should be a function there which is handling the actual segmentation faults. Dash C on. At least it should be. Not quite sure how some of this stuff's working though. Hmm. So, this code right here is what we're actually doing. So we set up, when we initialize it, we're going to capture the SIG V's, and pretty simply, yeah, it's pretty messy, right? So before every test, we copy what we're doing into a buffer, and we're going to write that out when a seg fault happens. So because of the separation of memory, it should work okay, although no guarantees. Or no, you're perfectly fine. Having people to talk is very, very useful. Um, hmm. So one of the things that I was really concerned about when we started doing this is that we aren't going to just have one. Are you using a random variable as a pointer to the buffer? No. So we're calling malloc with a large enough size to force malloc to back it with mmap, that it will be separate from the Python heap, wherever that is. And the hope here is that by doing it this way, we're going to end up with something a little bit easier to work with. But it would appear this is not working out the way that I want it to. Because, so one of the things I was pretty concerned about is if we get heap corruption in our Python, then there's a very good chance that the function that actually causes it is not the one that actually causes a seg fault. So I guess one of the options is we could recompile Python with like asan, which would work for that. Or I could log more stuff. I don't really want to try recompiling Python. Oh no, all the RNG stuff is being done in C. I'm using the pointer returned by malloc as a unique identifier for a crash. In terms of very hacky ways to do things. That way, it should be a unique name, because I'm including a pointer that is ASLR'd on a 64-bit system in the file name of the crash. So that should be a unique identifier, especially since we're only running to our first crash. Yeah, there are binaries that are compiled with asan, but they're no. I would need to compile numpy with asan, wouldn't I? Or Python? Both? I actually don't know which one it would need to be. Hmm. Because clearly we're not capturing enough information. We need to capture more of a log to get someplace useful. Because we're catching seg faults, which is awesome. I'm glad this is working. Given how like hacky a lot of this code is, I'm a little bit surprised that it's um yeah, that's actually if you go back in the stream to when we were first starting, I was actually discussing exactly that. Like I need a random identifier so that if I catch multiple seg faults that we get different versions. But there's only going to be like 24 bits worth of randomness here. So if I end up getting, a few 100,000 unique crashes, then this isn't going to be sufficient. And at that point, I was like, you know what? If I'm doing that, we already have enough crashes, and I don't care about losing a few. Um, hmm. Right. So that's the reason we're trying to fuzz numpy is because it's mostly written in C, and hopefully it works. But I don't know. Hmm. This is unfortunate. I'm not sure what the right approach here is. So I think so. One way to do this is to have a rolling group. So I want to have um, instead of having one buffer. Nope, nope. Ah, god damn it. I've ranted about this one on stream a number of times now. I don't think I have literally ever hit F1 in a terminal and wanted help to come up. So, yeah. Oh, no, 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 you're fine joining late. Taking the 30 seconds to explain it is well worth the time. Um, okay. Speaking of writing awful code to fix all of our problems, so we have this, and I want to print out this. So this should let us print out the past 4. If we do modulus 4, we have plenty of space for 8 times 4 is 32, right? Yeah. So this will save off the past 32. So I should be able to do for I is equal to 0, I is less than 32, I plus plus. Star TMP. P is equal to buffer plus OX 2000 times I. TMP len right fd /n/n/n. Oh, 3. C types make. Damn it. Not declared in. Oh. I am actually kind of shocked that GCC is like, yeah, that code is fine. I am happy with that. But I'm not going to complain too much, am I? Okay. So, that code does what I think it does. instead of keeping one, the last function we fuzzed, we're actually keeping the past 32 functions we fuzzed. So ideally what we're going to get here is if we ever get a seg fault, the past several functions dumped out, and one or more of those is going to be, one of those is the one we want. This is the problem with fuzzing things that we expect to find heap corruption in that I don't know if where I get heap corruption is going to be, like where I get heap corruption is rarely where the crash happens. So I need to actually figure out like where that's happening and try and get something out of it. But come on. Crash. Crash. I need to figure out what's causing this spin. It might be exponentiation, which is, I guess, kind of to be expected. This in case there's some... Well, so what I'm guessing is there's something we're doing is causing heap corruption, and then so we define a function. When we call that function, it causes some heap corruption, but it's able to return fine. And then, 3 or 4 functions later, when we, make an allocation or something, that causes the actual crashes that we were seeing. Because the stuff that was being logged in our crashes is clearly not sufficient to cause a seg fault. My guess is that we're getting heap corrupt, like we were getting heap corruption. We just weren't logging the functions that were actually causing the heap corruption. So now we've got this like rolling thing that we're doing, and hopefully the 32 functions will contain whatever actually caused the heap corruption. But we'll see. Because, amusingly, now that we've recompiled the .so, it is... Of course, all I have to do is start saying something, and it will prove me wrong. Okay. So, these are the last 32 functions. So first off, looking at this, I'm bad and should feel bad. I need to put more spaces in. So let's start with that before we do too much. So when we do this, so defer should always have a new line when we append it. Plus 10. So this may or may not affect things. Ooh. That looks like it worked a lot better. FAO. Yeah, this looks like a real thing now. Okay. I will totally buy that this might cause a seg fault. This is A times 10,000? No. Okay. And there's a ton of these that are doing gross things. So let's actually modify where is this open? Open in one of these windows. Are you? Come back to me. Okay. cd c types s.c. So the first thing we're going to do here is let's sprintf currently on %x comma iter need r st26 c write fd st then e set st0. Okay. Is corruption doneer when? Quite possibly. I don't know. I mean, at this point, I have literally no idea what we're finding here. We're now actually generating objects in numpy and feeding them into each other and doing stuff. Um, so, like, it is entirely possible that all sorts of gross things are happening here. So, cd crashes ls-latr. I want to do vim crashes a09. This is the one I want. Currently on F. I really should get better at writing what I actually want to have happen. So I want to do write fd st comma sterlen. This and we're gonna do %d c types make okay. So we are currently on 6. So this is the thing that caused a seg fault. So we called this, 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 this. This seems plausible. No. Set no auto dent. Oh, come on. Word numpy as an e. Well, that is just bizarre. So supposedly, when we called this, this caused a seg fault. At least that's what our log tells us. That we were currently, oh no, we would in 5. Because 5 was the one that, it's interesting that at least this set of seg faults are all related to these records. Um, although I don't know how much that matters. So let's try this again. Copy that, repro, G. That. Not defined. No. I want to call imp the that is not causing a seg fault. Will I push this code someplace? I don't know. It depends a little bit on where we get over the next few weeks. At least right now, I'm probably not going to push the code anywhere. Once it works, I'm gonna test it a little bit more. So one of the things that I think so we've been doing these 0 day streams on Wednesdays for the past month or two. And at least one of the things that I wanted to do with them was to make sure that the target selection was not, that we were not looking at things that would have direct relevance, security problems. So I don't want to like go on stream, find a bug, like write an exploit for it, for something that somebody's going to turn around and throw at everybody on the internet and cause problems. If it turns out that like Python has a ton of major issues, I'm probably not going to release the code right away. At the very least, it would be after a bunch of them get fixed. Like submit some bug reports, see where we get. Um, but for the immediate term, the answer is no. The code isn't being released. In the long term, maybe. I don't know. Um, and I'm not sure. Once we get someplace useful, then I'll know. But at least for now, I have no idea um, when. Holy crap, that's reproducible. Huh. Well, you look at that. We actually found a crash. I'm a little bit surprised by that. That we were able to find a crash in 3 hours. Like my fuzzer actually found crashes. Huh. Wow. What's a null deref? That's good, right? Like it means that this actually works. So if we put some time into it, we should be able to create a. So let's actually talk about what's happening here, right? So this right here is more or less what our fuzzer generated. And what it generated was that it's going to call this function, which is this right here. That's going to call numpy.v dot with 2 arguments. The first argument is creating a u byte, whatever that is. And the second argument is creating a big record. Now, I don't know why it's a null deref, and it's definitely going to be worth digging into, but that is definitely causing a null deref and something with multi-array. Um, what it is, I don't know, and we'll have to dig into it later. Um, so yeah, it's good to see that that works. So before we finish for the day, what I want to do is write a little bit more code. So the current version of this, when we catch a seg fault, we immediately end. And that works fine. Like we're able to sit here and I can sit here and go, uh, run, 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 catch a crash, run, 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 catch a crash, run, 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 catch a crash. But if I want to actually find all the crashes, I need to. Wow, what is that doing? Like it's. I'm actually kind of excited that it's managing to generate some of this stuff. So like some of these things that it's generating are pretty crazy. DD crashes ls-latr crash de, like the fact that we're creating some of these we're creating complex numbers and passing them into different things and creating like valid complex numbers. So in this case, 3 is the one that caused the crash. We broadcast something which has a iterator, a time delta. We vectorized two different, or we vectorized the same. So we vectorize a data source. We would vectorize a data source twice, and I'm not sure what we're doing here. So, like I was saying, before I end the stream tonight, we've been going at this for about 3 hours. The last thing to do is I can run this and get a crash. However, I don't want just one crash. I want hundreds of crashes. I want thousands of crashes. So I'm going to write the quick and dirty and awful way of doing this. I'm going to write in Python vim wrapper.py. We're going to use pwn tools because I know how to do all of this off the top of my head. While one, we're going to just call. So s is equal to process python test harness.py shell is equal to true s dot clean. So all this is working correctly. That is not doing what I was hoping it would do. I mean, I guess it is. That is definitely catching new crashes. Again, it's not doing quite what I want it to do because ideally I would be getting, like, it's not closing some of these, but it kind of works. And this is, again, just being absolutely gross about how I am doing things. So, I think that's about it for this week. I'm going to run this over the weekend and until Wednesday. And so this Wednesday, hopefully we'll have some of these to go look at. We can dig into what some of these are doing. We'll write some code to triage them and take a look at them better. We're going to definitely probably write a better test harness than this piece of crap right here. Um, Something that I can actually sit here and run for a few weeks and see what we get. Outside of that, there's a couple of other improvements. So our generator right now doesn't handle, it does not call methods on the objects that are being returned. We need to add that support because without that support, we can't actually get the bug we started all of this looking for. Until that works, we're going to just be, ooh, we crashed bin.sh. How on earth did that happen? I'm not even going to ask questions about that one. But yeah, so this currently works. It's terrible, and it's like it is absolutely eating my entire CPU right now. Hopefully, the video streaming is not dying because of it. Um, but I think at this point we're going to call it a day. Next Wednesday at 7 p.m. Eastern, I will be doing some cleanup for this. We're going to start triaging these, take a look at them. Hopefully, we'll have some exciting things to look at that aren't just null derefs. So thanks everybody for tuning in, and I will see people on Monday for the CTF stuff. So the Monday stream, I'm not quite sure what I'm going to do because, well, I mean, right now there's the or not the PH Days CTF going on, and I was skipping that. We'll see what we do on Monday. I'm not sure yet. If people have suggestions, I would love to hear about it on Twitter. It's probably the easiest way to let me know. Other than that, I will see people on Mondays and Wednesdays. So thanks everybody for tuning in, and I'll see you guys later. Bye.